Okay, so Unit 3 is, we're not really going to learn anything new mechanically in Unit 3. What we are going to be doing is taking all the stuff that we've learned in the past and applying it in new ways. So for 3.0, what we're going to do is we're going to review some of the core concepts that we went over in the last few units to make use of during this unit. Okay, so let's start off with some of the basics. First of all, we can see that we have our slope, the equation for a slope, which is just the rise over run. So to get the rise, we subtract the two y points, so y2 minus y1. And to get the run, we get the two x point difference, so x2 minus x1. To find a midpoint, which we did in the last unit, simply add up the two x components and divide by 2. Then add up the two y components and divide that by 2, and that'll give you the x and the y of the midpoint between any 2 points. All right, great. So let's dig a little deeper here. Let's say we want to find the equation of a line, which we know is y is equal to mx plus b. Great. In order to do that, we're going to substitute the slope m and one of the points that we know, any point that we know that's on that line. And once we've substituted those three values, y, m, x, the only thing left is the b. So if we solve for the b, what we're really solving for is the y-intercept here. Great. That means we have all the values that we need to write out our equation of a line. Now this concept is not new, and we're going to apply that in a number of different ways and for a number of different purposes throughout this unit. A perpendicular line, we know that this has a negative reciprocal slope to the original line. So a negative reciprocal slope. What does that mean? It means, well, if m is equal to a over b, rise over run, then what that means is that m perpendicular is equal to negative b over a. So the negative reciprocal, we flip the fraction. Great, this is going to be really useful, and it's really easy to do once we know it. Now, the one thing you have to remember is sometimes you're going to end up with a whole number. Like, let's say, for example, you get a slope of m is equal to 2. Well, that's great, but you also know that that can be rewritten as 2 over 1. So when we rewrite that as m perpendicular, that's going to be equal to negative 1 over 2. So don't forget that there's always that kind of invisible 1 underneath the whole numbers if we need to. It's going to be very important going forward. All right, so let's start applying these things. So given some triangle ABC, we're going to try and determine the equation of the line that is perpendicular to the line passing through the points A, negative 6, negative 3, and B, negative 2, 5, that passes through the point C0. That was a mouthful. Let's kind of reword that because that's kind of confusing. First of all, the line, the original line we're talking about is AB. And what we want is the line perpendicular to that, but the line that is perpendicular to that will also pass through the point C01. So let's rewrite this. Let's say what we want is find the equation. Maybe this will help out a little bit. Yes, I got it. Thank you. Find the equation of the line perpendicular to AB. Now that perpendicular line will also pass through C. So we're going to say and passes through C. So with this knowledge, we should be able to get everything we want. So we know if it's perpendicular to AB, that means its slope is the negative reciprocal of AB's slope. So the first thing we're going to do is we're going to find the slope of AB. So we want to find little m AB. Remember, this is rise over run. Now, this is the line going from A to B. So x1, y1 applies to A, and x2, y2 applies to B. So keep this in mind when you're applying the slope equation up here at the top. So first of all, y2 is going to come from b. So that's 5 minus negative 3, which is from a. Subtract negative 2 minus, over negative 2 minus negative 6. Now we bring that all together and we get 5 minus negative 3, so that's the same as adding. So 8 over 2 plus 6, negative 2 plus 6. So that's the same as saying 4. So 8 over 4 can be reduced to 2 over 1. And you could also write that as just 2 if you'd like to. But because my next step is to find the negative reciprocal of that slope, well, I kind of need that fraction. So we're going to use this. We're going to say m perpendicular is equal to the negative reciprocal. So negative, because it's a positive right now, of 1 over 2. Great. Now we're going to substitute the negative reciprocal, our m perpendicular slope, and the point that it lies on the line we're trying to find, which is C, the only other point we know, into our standard line formula, and we're going to calculate for B. So y from C is 1 equals m, which is negative 1 over 2, x, which is also from C, which is a 0, plus b. Now 0 times anything gives us 0, so we have 1 is equal to b. Oh, that was nice and straightforward. So now what? Now we have all the information we need to actually rewrite that equation. So we could say y is equal to our slope, or the slope of our perpendicular line is negative 1 over 2. X, now plus our b, which is just a 1. There is our equation of our line. Now the final step says to graph the whole thing. Okay, let's do that. So first up, let's graph all the points of our triangle ABC. So negative 6, negative 3. So negative 6 is all the way over here, and down 3, 1, 2, 3, right there. So that's A. So we always want to label everything. I'm going to label all of our axes and everything like that while we're at it here. So we have A. B is at negative 2 all the way up at 5. Your B. And then C is at 0, 1. 0, 1, right there. Okay, so we can connect our lines here. I don't have a ruler because I'm on a computer, so I'm going to do the best I can. Whoa, we're going to undo that one. That was pretty bad. Let's try again. That's slightly better. Definitely not great. You should definitely be using a ruler when you do this. Now we know that our line passes through C at 0, 1 and is perpendicular to our line AB. Do we know where that line actually intersected with AB? No, that wasn't really part of our problem. So, but we do know the slope of our line. So we know it passes at 0, 1, and we know the slope is negative 1 over 2. So that means down 1 over 2. So right here, down 1 over 2, down 1 over 2. And we can go the opposite way too. Up 1, left 2. And then up 1, left 2. Now when we connect these lines, this is a much prettier picture, other than my amazing handwriting here. I guess there's a ruler up there that I could use. I should probably try using that sometime. Anyways, so we want to fill out everything we can when we're filling out this whole thing. So we've labeled our triangle ABC. We've also drawn our line and shown that it is a right angle, so we know that it's perpendicular to AB, and we want to label the line itself. So this one was y is equal to negative 1/2 x plus 1. That is a fully labeled graph, and that's the expectation we would see on your stuff as well, except with a much better version of lines, because you are absolutely going to use a ruler as opposed to me. Okay, so that's the start of our review. Let's keep going. We're not done yet. We're just kind of ticking away here. So let's scroll down to example number 2. So example number 2 is a similar idea. We got a whole bunch of different steps. We'll see if we can get it all done here. So this one is the similar idea. Determine the equation of a line that is perpendicular to the line passing through the points AB. So again, it's perpendicular to AB, and it passes through the midpoint of the line segment AB. Oh, well, that's interesting. So we know that not only is it perpendicular to AB, it actually goes through the midpoint of AB. That's going to be useful information. So first of all, let's do the same stuff we did last time. We're going to start off by finding the slope of the line that we are getting our perpendicular equation from. So, oops, undo. Where did the undo? There it goes. Ooh, I don't know why it scrolled like that. There we go. Too much. One click. Well, that's just frustrating. Let's tap it once. There we go. Okay. Trying to get as much screen real estate as we possibly can here. So let's find our slope. So it's our little m AB. So that means we're getting the x1 y1 from A and x2 y2 from B. So y2 coming from B is -2. Subtract 8 all over 7. Subtract -5. So that gives us -2 minus 8. That's -10. Over 7 minus -5. So that's just 2. So we get a slope of -5. Okay. Is that helpful? Did I do something wrong here? I feel like I did something wrong here. -2 minus 8. Oh, yes, I did. Yeah, this should be 12. 7 plus 5 is 12. So this is not 5 over 6. Or this is not -5. This is actually -5 over 6. We can reduce the fraction. There we go. There's our slope. So our perpendicular slope is going to be equal to the reciprocal, so 6 over 5, and negative of what they have, so that's a positive number. Great. So now we know our reciprocal slope. Now we have to find the point that it goes through, otherwise we can't substitute into the whole equation because we need a point as well as the m to substitute into the original equation. But we were told in the question that it goes through the midpoint. So let's find the midpoint of AB. So our midpoint of AB is going to be the sum of the two x's. So that's going to be -5 plus 7 over 2. And then the sum of the two y's, which is 8 plus -2 over 2. So that's going to give us -5 plus 7. That's going to be 2 over 2. That's just 1. And then 8 plus -2, that's 6 over 2. That's 3. Okay. So now we know the midpoint, which is 1, 3. So now we can substitute the slope here and the midpoint here into our equation and solve for the b, which is left over. So our y, which is 3, is equal to our m, which is 6 over 5. Oops, times our x, which is, we'll just write that in there like that. No, that's too terrible. We got to fix that. There we go. Times our x, which is just a 1, plus our b, which is what we're trying to find here. So 3 is equal to 6 over 5 still, because 1 times that is not changing it, plus 5, or sorry, plus b. Now we got to bring that 6 over 5 over to the other side, and we know that we're going to be subtracting because this is positive, and since this 3 doesn't have a common denominator, we got to get it to be a common denominator, which is 5. So we have to multiply the 3 by 5. So we're going to end up with 15 over 5 minus 6 over 5 equals b. That means b is equal to 15 minus 6, which is 9 over 5. Great. So now we have all the information we need to rewrite the equation, so we can rewrite it as y is equal to the slope, which is 6 over 5, x plus b, which is 9 over 5. So we have the whole equation. Now it says graph the line segment AB and the perpendicular line. So let's graph AB first. So A is at -5 all the way up at 8. So -5 all the way up at 8 right here. You are A. And B is at 7 all the way over here, -2 right there. So now if we try to connect the dots here, that's not too bad. And then our extra point here is, well, we know that it crosses through the midpoint, and we know the midpoint is at 1, 3. Okay, so 1, 3 right there. So that's where it crosses. Now some of you be like, well, we know the y-intercept. Let's put that in there. Well, we do, but 9 over 5 is not exactly a nice number to actually be writing on and finding the y-intercept. In fact, that's going to make it probably harder than anything. But we do know the slope. So rather than use the y-intercept, let's use the slope, which means up 6 over 5. So we're currently at 1, 3. So that means up 6 is going to take us all the way to 9. And then over 5, which is going to take us to 6. So 9, 6. I think that's it right there. So now, and we can go down the other way. So that would be down 6. 1, 2, 3. 1, 2, 3. And then over to the left 5, which put us at -4 right there. So now if we connect these dots, we have our perpendicular line, which is off from AB. We can also label this as y, and we should. Y is equal to 6 over 5, x plus 9 over 5. Don't forget to label your axes as well. All right. There is question number 2. We've graphed and we've shown everything we can there. And I think that's it for 3.0. The next lesson, again, we're not going to be learning anything new. We're just going to be applying the knowledge we have in new ways. So just keep that in mind. The more comfortable you get with doing these common operations of finding equations, substituting values in, knowing what you need to find, the better you're going to do at this entire unit. So good luck going forward.